Okay, good afternoon.
Good afternoon, Mr.
Okay, thank you. Let's start our today's discussion, which is about electrostatic. And last lessons, we have started discussing the definition of electrostatic, which is the study of an electric charge at rest. An electric can be in motion or it can be at rest. When we are dealing the properties of charges at rest, then it is studied under the field which is called electrostatic field. And as you know, an atom has electron and a proton. If an atom consists an equal number of proton and electron, electric charge will appear on the surface of atom, or it may be negative or positive, but there will be an atom with a certain charge, and this charged atom is called ion. And in a similar way, as you know, a substance is made up of atom. Even though there is a plenty of atom, then the same logic will be happen when an electron transfers from the surface of a substance to another surface, or from one region of a substance to the other region of a substance. And when the electrons movement or migration happens, then the body is said to be electrically charged, but the charge can be negative or positive based on the number of proton and the number of electron. As you know, proton is always in their parent atom or in their substance, but electron can move. Maybe it can move around a substance, or it moves to another object, or even it moves to infinite distance, or can move away from a substance surface. Then there are some mechanisms that help us just to charge, to make a neutral body to be charged. There are some mechanisms that help us a body to be electrically charged. And these mechanisms are maybe rubbing or friction. The other one is conduction for conductor, and it can be induction. So these are some mechanisms that help us to produce an electric charge, to make a body to be electrically charged. It can be positive or it can be negative, but it's possible just to change a neutral body into a charged body. But most substances are neutral. And the other one, there are some devices. For example, when we say electroscope, it's one of an electrical device that helps us to detect the presence of an electric charge, or even the magnitude of an electric charge, or the sign of electric charge. And we'll see the working principle of electroscope in laboratory, because this device is available in our lab. So it's possible just to see or to demonstrate the working principle of electroscope. The other device, which is also found in our lab, is which is called Van de Graaff generator. This Van de Graaff generator is one of an early discovered electrical device, and this Van de Graaff generator also helps us to identify or to demonstrate the presence of electric charge. We can see the movement of electric charge, or the beam of electrons. When electrons move from one body to another body, you can just see the beam of electrons, or even the spark of the spark that produced by electrons. When electron jumps from the dome shape of Van de Graaff generator, then they produce a spark, or they produce just like a thunder sound. And as the other point that we need to discuss today is the distribution of charge on a conductor. Charge on a conductor can flow from one point to another point, but when they just move on the surface of a conductor, they move just uniformly, or they distribute uniformly, they spread uniformly in every part of the conductor, if the conductor is a regular shaped conductor. If just the conductor is like a sphere, metal sphere or conducting sphere, then the charge will distribute uniformly on the outer surface of a sphere or a regular conductor. But what if the metallic conductor is not regular shaped? If it is sphere, for example, charge will distribute evenly. If the net charge is negative, then they will distribute uniformly in each parts of a sphere. Whereas rather than regular shaped, if it is irregular shaped, if there is an edge or sharp corner, then what will be the distribution of charge on regular conductor? We know that the net charge is on the surface of a conductor, not inside. Inside is not a net charge. The net charge is found on the surface of a conductor. Then when a conductor has a sharp corner, then there will be a much accumulation of charge on the sharp corner rather than the wider part. The sharp corner will have more charge, or charge will accumulate, or more charge will be found at the sharp corner. So at this point, there is more charge. There is more charge. Charges at a sharp corner. At the sharp corner, there will be the accumulation of charges. And the other point is about the formation of thunderstorms. Then there will be cloud on the sky, and this cloud moves from one part to the other. And when they are moving when they are in relative motion, which means there are different layers based on the temperature difference. The one which is near to the surface, and the other one is just a layer which is formed above the first layer. And there will be, due to a wind, there will be a relative movement between the layers of a cloud. And when these layers, one is moved to the left while the other is moving to the right, there will be friction, a sort of rubbing or friction. Due to this relative motion of a layer, if one layer moves above the other layer or over the other layer, charge will form. Because, as you know, cloud is a drop of water. And as you know, water is made from hydrogen and oxygen. And due to this high and relative motion, there will be a dissociation of water molecules, which means positive and negative ion will be happened. And a layer that is with that contains much ion of hydrogen will be slightly positive, and the other layer will contains high amount of oxygen ion will be slightly negative. There will be, therefore, there will be two separate layers, or two layers with separate charges. One is slight positive, and the other one will be slightly negative charged cloud. Since there is two types of charges, a layer with two different charges, then they make a neutralization. For example, electron may flow from a negative region to a positive region. While this process taking place, there is a process which is sparking of lightning is formed, or sparking will be formed and a lightning will be formed. And this lightning maybe will be grounded, or the one which is near to the earth, the layer which is near to the earth may get electrons or may receive electrons from the ground, or it may just lose electrons to the ground. And due to this process, while the charge is moving, the charge will form some Coulomb, and through that Coulomb, charge will flow to the ground, or from the ground to the layer. And due to this process, there is, due to this movement of lightning, there will be a huge amount of energy will be just involved in this process. And as a result, you may hear some thunder. There will be a loud or huge sound which is called thunder. So thunder is the result of a discharging process, the result of a discharging process. For example, electrons may move from ground to the layer, or electrons may move from a layer to the ground. And due to this process, there is a thunder sound. And to protect from this lightning, we use lightning rod. This is common for a building, just to protect a building from the lightning hazard. This lightning by itself is an energy and can just bring a hazard, or some bankruptcy will be happen due to this lightning. And to protect the buildings from this hazard, every building has a lightning rod, which is a metal rod conductor made from copper or any other good conductors. Then this rod will erect over a building roof, and the other end will be to the ground. And when a cloud is moving around the building, before a hazard has happened, then electrons or excess charges will flow through this metal rod into the ground. So this metal rod protects a building by neutralizing an excess charges. If there is an excess charge, then excess charge will be flow through a lightning rod. The other one, there is an electrostatic force. We said that even though charges are not in a motion, they will have some properties. One of the properties is electric force. This electric force is a force exists between charged bodies. If we have two charged bodies, the two bodies may carry the same charge or different charge. Whatever the sign of a charge, there will be an electric force or electrostatic force that exists between charged bodies. As a force between charges that are at rest is called electrostatic force. It is called an electrostatic force because we are dealing a charge at rest or charges at rest. And if we are considering a force which exists between charges at rest, then the types of force is called electrostatic force. Then the amount of force with which two charges are repelling or attracting each other as determined by a Coulomb's law. And one of the law in physics, there are a number of laws. For example, we have law of reflection, gravitational law, or maybe any other laws like Coulomb's law or Ohm's law. So this Coulomb's law is one of the law in physics, which is proved because this result is always true. A force that exists between charged body at rest is electrostatic force, which is directly proportional to the product of two charges. We have two charges, Q1 and Q2. And assume this Q1 and the Q2 are point charges, for example. This one is Q1, and this is Q2. And there is separation between Q1 and the Q2, which is R. Then this force has a direct relation with the product of two charges and inverse relation with the square of separation between the two charges. So this is called Coulomb's law. And this result is always true wherever you do an experiment. For example, all over the world, at any laboratory, or by using any maybe procedure, then we can produce the same result. Electrostatic force is directly proportional to the product of two charges and inversely proportional to the square of a separation distance between two charges. And mathematically, it can be expressed as 1/4 pi epsilon naught times Q1 times Q2 over R square. So this 4 pi is a constant number, and epsilon is a constant which is called permittivity of free space, which is the permittivity of free space and has a value. But rather than using epsilon naught, it's better to have another constant. Another constant which is called electrostatic constant. Therefore, rather than using this 1/4 pi epsilon naught has an approximate value 9 times 10 raised to 9. 9 times 10 raised to 9 Newton meter square over Coulomb square. Newton times meter square over Coulomb square. This is called K, which is electrostatic force constant. Electrostatic force constant. Therefore, we can rearrange the force as K times Q1, Q2 over R square, where K is electrostatic force constant, which is equal to 9 times 10 raised to 9 meter square, Newton meter square over Coulomb square. This is a very reduced form of electrostatic force. This is electrostatic force, simply electric force. This is an electric force at rest. Then let's see one simple example. We have 2-point charges, which is 60 nanocoulomb and 3 nanocoulomb are placed 30 centimeters apart. So we have two charges, point charges. One is 60 nanocoulomb and the other one is 3 nanocoulomb. So these are two charges, point charge, and a distance between these 2-point charge is R equals 30 centimeters. Then we are looking to find a force that exists between these two charges. So first, we have to convert the charges into their SI units and the separation distance into SI. And for example, Q1 is 60 nanocoulomb. Instead of nano, we can use 10 to the power of minus 19 because it's some multiple of a prefix. Then 60 times 10 raised to minus 9 coulomb, or by cancelling 1 zeros, we left with 6 times 10 raised to minus 8 coulomb. This one is charge 1. And in similar way, charge 2 will be 3 times 10 raised to minus 19 coulomb. And the fourth quantity is separation distance, which is 30 centimeter. And when it's converted into SI unit, it becomes 0.3 meter. And we know that force constant is a given, which is understood. And the value is 9 times 10 raised to 9 Newton meter square over Coulomb square. Then by having these quantities in our mind, we can find the magnitude of a force that exists between Q1 and Q2. Then you will try it. Then what will be the value? We have given quantities. Q1 is 6 times 10 raised to minus 8 coulomb. Q2 is 3 times 10 raised to minus 9 coulomb. R equals 0.3 meter. And K equals 9 times 10 raised to 9 Newton meter square over Coulomb square. And a solution for this problem is force electrostatic force equals K times Q1 Q2 over R square. Then what will be the final answer? F equals 9 times 10 raised to 9 times 6 times 10 raised to minus 8 times 3 times 10 raised to minus 9 divided by 0.3 the whole square. Then 9 times 6 times 3 times 10 raised to 9 minus 8 minus 9 divided by 9 times 10 raised to minus 4. Then this gives minus 8, and we do have minus 4. Then 9 will be cancelled by 9, and 18 times 10 raised to minus 8 plus 4. When a negative exponent is taken to the numerator, it becomes positive. Then finally, we left with 18 times 10 raised to minus 4 Newton, which is a force exists between two charges. Yes, do you have any question?
No.
Okay, just let's summarize a main point that is the pinpoint of this lesson. The first one is distribution of charge on a conductor. In the first place that you need to know is the net charge on a conductor is found on the surface, not inside, but on the surface of a conductor. The net charge is found on the surface of a conductor. And this charge is delocalized charge, or they can move here and there on the surface of a conductor. Simply, they are delocalized, or they are not highly tied by a certain atom, so they are not belong to only for a certain atom, so they are free to move on the surface of a conductor. Then when the shape of a conductor is regular shape, the charge will distribute itself evenly or uniformly. They spread out on the surface of a conductor uniformly or evenly without just being just scattered on the other one and being denser on the other place. So they become a uniform distribution. But what if there is a sharp corner on the conductor? Charges will accumulate more on the sharp corner of a conductor. So they will migrate or they will move to the sharp corner of a conductor. And the other one, the formation of thunderstorm. The formation of thunderstorm is due to rubbing process, due to friction process. Because as you know, in cloud, in the rainy season, there is cloud, and a cloud will form layers, and these layers move or have a relative motion one to the other, or one layer will move over the other layer. And this relative motion, then there will be dissociation of water molecules. Then there will be a charge separation. In one place, there will be more charge, positive charge, and in the other place, more negative charge. Then relatively or slightly, they become negative and a positive. And since a negative and a positive layers of a cloud may meet at somewhere, then when they meet, there will be neutralization or discharging process. And the discharging will take place in a very short fraction of time, and will form just some sparking of lightning, and they will just produce some energetic light. And when this light pass through a cloud or no, an air, it produces sound, which is called thunder sound, or a very huge sound. And this thunder or lightning has hazard, or it can just collapse maybe buildings or any other infrastructure. And to protect this infrastructure from just being collapsed, then we have to use a lightning rod. And this lightning rod, the purpose of this lightning rod is to make neutralize or to flow electrons safely without having or without bringing an hazard. Therefore, by this process, we can protect from lightning by using a lightning rod. The other point is about Coulomb's law. Coulomb's law is one of the law in physics, which is a very known law, and that determines the nature of electrostatic force, and it helps us to determine the magnitude of electrostatic force. the nature of, when it says nature, the force can be repulsive or attractive. So this law helps us to determine the nature of an electrostatic force and the magnitude. And it says there is a force between 2-point charges, and the magnitude of the force is directly proportional to the product of two charges and inversely proportional to the square of distance between them. And by having these concepts in our mind, we can write the formula for electrostatic force. And the formula is 1/4 pi epsilon naught times Q1 Q2 divided by R square. This Q1 and the Q2 are net charges on two bodies, and 4 pi is a constant. Pi is a number, and 4 is a number which is constant, and the epsilon naught is called a permittivity of free space. It tells the permittivity or the tendency of a space to permit a force that exists between two charges, because the charges are supposed to place on a space, and the space has its own permittivity value. But instead of space, if the two charges are placed on air or on a material, then the permittivity, this will not be epsilon naught. The other permittivity value will be used. So this is the permittivity of free space, which means the permittivity of a vacuum. If the two charges are placed in a vacuum, we use epsilon naught. Whereas instead of just free space, if there is a material, or if the two charges are placed between materials, then the materials will have their own permittivity value. But rather than using 1/4 pi epsilon naught, we look another constant, because these four quantities are constant. 4 pi and epsilon naught are constant, and by bringing them into calculation, we can produce another constant, which is called force constant, electrostatic force constant, and its value is 9 times 10 raised to 10 the power of 9 Newton meter square over Coulomb square. So this is a constant value. Whenever we are calculating a force, this constant value is needed, and simply the formula becomes K times Q1 Q2 over R square. Then this is the reduced form of, this one is the reduced form of electrostatic force, or the reduced form of electric force when the charge is at rest. And we have seen one problem, which is about a charge between two, a force between two charged point charges, two charges, which is 60 nanocoulomb and 3 nanocoulomb. And as these charges are placed, assume in a free space, just 30 centimeter apart. So there is a distance between them, which is 30 centimeter. And then first, we have to use the SI units. And instead of nano, we can substitute nano by 10 to the power of minus 19. And the constant value is 9 times 10 raised to 9 Newton meter square over Coulomb. Then by substituting these all values, we get 18 times 10 raised to minus 4 Newton. We can treat exponents at once and the base numbers at once. Then simply, or you can use any simple method just to handle the computation or the calculation. Then it becomes 18 times 10 raised to minus 4 Newton as a force that exists between these two charges. Okay, thank you very much. This is the end of our lesson.